Okay, college algebra, where you're going to do some coordinate geometry. Coordinate geometry just is kind of a focus on the coordinate plane, and different formulas are used. In this situation, the distance formula. Distance formula is square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And if that looks familiar, it's because you've seen it before, but also it is simply just a squared plus b squared is equals c squared. So I'm going to give you just a little bit of an idea of what that looks like. If you have two coordinates, so you have x sub 2 and y sub 2 here, and then over here you have x sub 1 and y sub 1. And you would like to find the distance between those two. Well, as you consider the distance, you can simply make it into a right triangle, and that length becomes the hypotenuse. This horizontal distance here is whatever x sub 2 minus x sub 1 is, and then this vertical distance is whatever y sub 2 minus y sub 1 is. And so if this is the distance, you can see that the distance squared is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And as you square up both sides, you do get this distance formula that sits right here. So the distance formula, again, it's just the Pythagorean theorem. The midpoint formula, you add the x values and divide by 2, and you add the y values and you divide it by 2. So that's the midpoint formula. So it says a pair of points is given, plot the points in a coordinate plane, and find the distance between them and the midpoint of the segment that joins them. So negative 2, 4, so back 2 and up 1, 2, 3, 4. And then 3, negative 6. 1, 2, 3, and 1, 2, 3, 4, 5, 6. So if I want to find the distance, square root of, we have x sub 2, which is 3, minus x sub 1, which is negative 2. We square that. Plus y sub 2, which is negative 6, minus y sub 1, which is 4, squared. 3 minus negative 2 is 5, squared is 25. And negative 6 minus 4 is negative 10, squared is 100. And so we get the square root of 125, which is 5 roots of 5. So that's the distance. For the midpoint, we add the x values, negative 2 plus 3 divided by 2, and we add the y values, 4 plus negative 6 divided by 2. Notice you get 1/2 and negative 1. Now, if we check 1/2 negative 1, that should be about the coordinate of the midpoint, which you could see if you kind of look at your drawing, it looks like that fits. So I don't think we have to do the second example. The use of the midpoint formula and the distance formula is something you've seen before, and I think one example is pretty good. But I would like to apply it to this idea of drawing this triangle formed by the coordinates 2, 2, 5, 6, and negative 3, 2, and deciding what kind of triangle it is, as well as the area. So here's 2, 2, and 3, 4, 5, 6. 2, 3, 4, 5, 6. So over 5 and up 6. And then back 3 and up 2. Now, when we classify triangles according to angles, we have right, we have obtuse, and we have acute. When we classify according to lengths, we have equilateral, we have isosceles, and we have scalene. So I'm going to look at this and say it's definitely not equilateral. But we can determine what kind of triangle it is by finding the length of the segments. This one's easy to find. You can see it's 2 over in one direction, 3 over in the other. It is 5. And instead of using the distance formula here, I'm going to use the Pythagorean theorem. Notice I go over 1, 2, 3 tick marks, and I go up 4 tick marks. And many of you remember that that makes a 3, 4, 5 special right triangle. There's also 5, 12, 13. There's 7, 24, 25. There's 8, 15, 17. I'm sure you remember all those. I'm joking. I know you don't. Teaching this class year to year, we come back to this point. But it does work out that those are all right triangles. So when you have a 3, 4 are the sides, you know that 5 is the hypotenuse. It also works out that any multiple of those. So example 3, 4, 5, if you had 1.5, 2, and 2.5, since that's exactly half, you know, that works out as well. But if you try the Pythagorean theorem, it will work out. So it looks like we have a length of 5 and a length of 5, and I know that this is definitely, this length is greater than 5. So it looks like we're looking at a isosceles triangle. And the last question is, what is the area? And the formula for area is 1/2 times the base times the height. And in this situation, the base is easy to see. It's 1/2 times the base, which is 5. And then to determine the height, you know, it's not a right triangle. You know, you don't have a right triangle. But if you notice, we created this right triangle right off to the side here, and it tells us that from the base to the top point is exactly a height of 4. And so that makes it an easy problem. 1/2 of 20 is 10. That is, in fact, the area. So, you know, solving problems like that is a nice, intuitive way of kind of working through some of the ACT problems you might get someday. You wonder, what does this have to do with circles? Well, circles are directly related to this idea of the Pythagorean theorem. A squared plus b squared is c squared. And if you think about a circle just has, you know, really two properties. It has a center and it has a radius. And once you have that radius, if you just kind of, you know, stretch it out in different directions, that's going to give you your circle. So it turns out that an equation for a circle is x minus h quantity squared plus y minus k quantity squared is r squared. That is exactly the same thing as the distance formula. If you look back at some of the information I brought up earlier, you can see that, where'd it go? Hey. Oh, looks like I must have erased it. Oh well, that's fine. Yep, I erased it. I don't see anything there. No, here it is. There we go. So you notice our equation was r squared equals x minus h squared plus y minus k squared. So the letters are just a little bit different, but instead of distance, we talk about a radius. You can see the x values, h is the shift, and then the y values, k is the shift, and there we have it. So it works out really nicely because it is simply just the Pythagorean theorem. Again, c squared is equal to a squared plus b squared. So distance formula, Pythagorean theorem, and circles all really are the same in that they come from the Pythagorean theorem. So if a circle has center 0, 0, in this situation, h is the center for the x value and k is the center for the y value. So if you plug in 0, 0, you get x minus 0, which is just x squared. And then if you plug in 0 for k, you get y squared, and that's equal to r squared. So x squared plus y squared is r squared is a circle with a center at 0, 0. So it says write an equation for a circle as the following properties. Center at -3, 2 with a radius of 4. So I use my formula. X minus, or this is h, this is k, and this is r. So x minus -3 squared plus y minus 2 squared is 4 squared. Now, we never leave the equation for a circle like that. We would write the equation as x plus 3 quantity squared. So y minus 2 quantity squared is 16. And so look at what you've done. You've written an equation for a circle that's centered at -3, 2. What does that mean? That means that if you were to draw it on a graph, it goes back 3 units and it goes up 2 units. So that's the center. And then it's stretched out 4 units in each direction. 4 units in each direction. Okay? That's your circle. That's what we've just done is written that equation. Notice that the hk values, that the x plus 3, that matches up with the -3, and then the y minus 2 matches up with the positive 2. So it's opposite of what you think. Look at this one, center at 0, -5. Since there's 0 for the x, it's just going to be an x squared. And then remember, it's y minus a -5, so y plus 5 quantity squared is, the radius is 1/2, I square 1/2, and I get 1/4. 1/4. What about a center at 3, 0? So it's an x minus 3, and then that 0 for the y is just going to be a y squared. If you square the radius, if we square 3 roots of 2, that's 3 roots of 2 times 3 roots of 2, or 9 roots of 4. Well, the root of 4 is 2, times 9 is 18, so that's what we get. This one says identify the center and the radius of the following circles. The center is going to be 3, -2, and the radius, because I have 16 here, is going to be 4. It's the square root of that thing. For this one, the center is 0 for x and -3 for y. Whoop, I don't write that squared. Sorry. And the radius is the square root of 48. What perfect square divides evenly into 48? 16 does. And I get 4 roots of 3. Okay. Sometimes we get equations that are not in the form of a circle. And this one is a circle, but it doesn't look like a circle. So we're going to place it in the appropriate form and identify then the center as well as the radius. And what I do is I gather together my x's. I'm going to put the 7 on the other side. Notice our formula for circles are x minus h quantity squared, y minus k quantity squared is r squared. So this has a completed square. Actually, it has 2 of them. And right now, my equation does not have a completed square. In order to complete the square, I will add 16. Because I take 8 divided by 2 is 4, square root is 16. If I added it to one side, I add it to the other side. -12, if I divide that by 2, I get 6, square root is 36. Add the 36 to the other side. Notice what we now have. X minus 4 quantity squared plus y minus 6 quantity squared is, see, we have 23. 23 and 36 make 59. Therefore, the center is 4, 6. The radius is the root of 59. Let's try it again. This time we don't have any other x squareds. So x squared is by itself. But I do have some other y's. So I have y squared minus 6y. And add 9. X squared plus, this is y minus 3 quantity squared, is equal to 16. So it looks like the center is 0, 3, and the radius is 4. Last question. Find an equation for a circle whose center is -1, 2, and passes through the point 7, -13. So if you think of this graphically, center is -1, 2. So back 1 and up 2. And it passes through the point 7, 13. So over 7 and down 13. So 7, -13. So, the circle looks something like that. Well, that's going to be the radius. And we don't know what that is. But we do know this, that for x minus h squared plus y minus k squared is equal to r squared, we know it's going to be x minus or plus 1, because we have center at -1, and then y minus 2, because we have center at 2. That's equal to r squared. So in order to finish writing this equation, I just need to know the distance from here to there. And you can use your distance formula, or you could think of it like the Pythagorean Theorem. If I want to go from -1 to 7, I have to go 8 units. If I want to go from 2 to -13, I have to go 15 units. And maybe you remember from our special right triangles that this is going to be 17. So some people write the answer as x plus 1 quantity squared plus y minus 2 quantity squared is equal to 17. And that's not correct because it needs to be r squared. If you square 17, you get 289. So completing the square and writing equations for circles is something that you have to be able to do. It's a good skill. You're going to use it for the rest of the year, even when we get to trigonometry. So good luck. Nice video. Should take care of it for you.